What can you make with hydrogen peroxide, yeast, PVC pipe, cigars, and balloons? Well, you can make an aluminum cutting torch. Welcome to the video. I've always been a little bit of a pyromaniac. From a gingerbread house to my own hand, I like to start fires. So, for my Chem and Captivity video, I chose the topic of torches and lighters. I use lighters to light a fire in my wood stove, and I always carry a lighter and some matches when I'm hiking in the mountains. I use a propane torch occasionally at work when the lock for the gate guarding the propane tank gets frozen, which is a little bit ironic if you think about it. Now we are going to put some hydrogen peroxide and measure it in grams. We're going to put about 118 grams in. Now we're going to switch funnels. The yeast doesn't really matter in here, it's just a catalyst, probably. And then we're going to put it in and then hope, well, just stretch out the balloon. Should have done this before the video. Okay. Oh, shoot. After 3 repetitions of the process, the balloon circumference was measured at 62 centimeters. From this measurement, we can find a rough estimate of how many liters of oxygen were produced from the reaction. Using the equation, circumference equals pi times diameter. So we get 62 centimeters over pi, which equals 19.73 centimeters. We then can find the radius, which is 9.9 centimeters. From this, we can use the volume of a sphere to estimate the balloon's volume. We plug in our numbers and we get 4,064 centimeters cubed, which is the same as 4,064 milliliters and the same as 4.1 liters of oxygen squared. Now we are going to do the chemistry way with stoichiometry and dimensional analysis. So in the total experiment, 356 grams of hydrogen peroxide were used, and it was a 3% mixture. 1 mole of H2O2 is the same as 34.014 grams H2O2. And there's the stoichiometry balanced equation for the reaction with yeast as the catalyst. We get 1 mole of O2 for every 2 moles of H2O2. And since this experiment was performed at 8,800 feet, instead of just using the molar volume of gas which is 22.4 liters per mole, I had to use a correctional factor of 1.34, which turns out to be about 30.016 liters of O2 per 1 mole of O2. And after we plug in everything and cancel units, we are left with 4.712 liters of O2. As you can see, 4.1 liters O2 compared to 4.7 liters O2, the chemistry version is a lot bigger. And there's a reason for this. The math only considered the balloon circumference. But as you can see here, the bottle is full of hydrogen peroxide at the beginning of the lab, and then after the reaction, it's full of water. But there is a bunch of space above those arrows, uh, which is not water. And so it for this experiment, we'll assume that it is 100% oxygen. So we find the volume of that and subtract it from the total amount of oxygen made. And so that turns out to be about 4.0 liters after rounding. And so 4.1 liters O2 to 4.0 liters O2 is pretty close for dirty numbers. Hello. This is my assistant, Annie, my sister. She still trusts me, apparently. And we got our safety equipment, our fire extinguisher, gloves, and glasses. And we are on a little bit of snow, so if it does catch something on fire, that should be okay. Yeah, here we go. Annie, you can light it. You can see here that kind of cuts tinfoil. Sort of.
Next.
Okay, that's it. As you can see from this video, the tinfoil was not being cut by the torch, and there was a few factors to this. One, I wasn't holding it close enough, really, and two, I also wasn't letting enough oxygen out. Here's another clip where it worked a lot better. Now we'll go on to some wood burning, maybe.
My sister.
Kind of working. It's not super hot. Oh, let's try it.
Oh. Get closer. Get on closer.
And I'm not very good at wood burning, so we'll put... Okay, now we're gonna just try to put a lot of heat on a quarter. So, in conclusion, lighters and torches work similar to each other. A type of fuel is pressurized in a container, so when a lever is depressed or a knob turned, the fuel stored as a liquid releases and vaporizes. An ignition source is activated, and the gaseous fuel reacts with O2 and combust. Depending on the type of torch, it may either use oxygen from the air or have a separate tank filled with O2. Lighters generally run on butane, while oxy-fuel torches most commonly run on propane, propylene, methane, and acetylene. The only real difference to the basic torch workings previously mentioned is the fuel type, acetylene. When acetylene is pressurized above 15 psi, it can violently explode. So, to prevent fireballs and death, acetylene is dissolved in acetone, and the container has a porous interior, which stops the decomposition reaction from occurring. In my cigar torch, the tobacco served as the fuel, and the O2 from the balloon intensified the fire so that it could cut aluminum. Thank you for watching my video. Here are my works cited. Have a great day.